Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. Yesterday, we looked at information on generally identifying the major plate boundaries, and as well as that, not only the plate boundaries, but you also supposed to have made note of the many different tectonic plates that are found on the surface of the Earth. Your homework yesterday was to look at the general direction in which those 7 major plates are actually moving in. We'll check on that particular homework now, and we'll also make correction to that homework. It is important for us to actually note the general direction in which the plates are moving so that we can be able to move on to our lesson for today. And our lesson for today will basically look at those general movements and the many features that are created as a result of the plate movements. Okay, the homework. Note the 7 major plates. We'll start off with the Indo-Australian Plate or the Australian-Indian Plate. The general direction in which it is moving would be to the north or the northeast direction. If you have that, that would still be okay. Generally to the north, that's the movement that that place, sorry, not movement, but that's the direction that that plate is actually moving in. The next one is the Pacific Plate. The Pacific Plate, direction in which it is moving is to the west. We're giving only the general direction in which those major plates are moving in. We look at the African Plate. For the African Plate, the general direction in which it is moving to is to the east, towards the east. The Euro-Asian Plate. The Euro-Asian Plate, southeast. The South American Plate, generally to the southwest. If you had the west direction, that's okay. But if we look at the general movement towards the southwest. The North American Plate is moving in a northwesterly direction. And finally, the Antarctic Plate, south. Okay, the Antarctic Plate to the south. And those are for the 7 major plates. You can also identify the movement of the other 12 or 16 minor plates that we looked at and we made a list of yesterday. How were you able to actually identify the direction, or from what did you look at to help you identify the general movements of those 7 major plates? Ovio, what did you have to look at to help you identify the general direction?
The arrows placed on the figure.
Okay, good. So generally on tectonic plates, if you are given a map, it will actually show you also arrows, and those arrows are supposed to indicate the general direction in which those plates are moving. Okay, and that is the homework you're supposed to have done. You can make corrections and we will move on with our lesson today. So if you look at an example of how you were able to identify the movements of those major plates, you simply looked at the arrows. And those arrows on the map, they generally indicated the direction to which those major plates were moving. Similarly, the minor plates, say for example, if you look at the Iranian plate, you can tell from the arrow which direction it is moving to, and also the Arabian plate, and similarly for all the other plates that we've made a list of yesterday. Before we look at the general direction of plate movements and also the features which are created as a result of the 3 main movements that plates would usually do, I'd like us to go back and look at some of the important terms that we have already covered in our work on plate tectonics. And to emphasize again on those major terms or some of the important words of which we will come across when we're looking at our work on plate movement. Tectonics, note, is the study of large-scale movement and the formation of the Earth's outer layers, mainly the lithosphere we're referring to here. You also note that by this time you would already have come across a word which is called sial. And generally when you're looking at this particular word, it is to do with the light rocks which are rich in the minerals silica and alumina. That's why you have Si for silica and Al for alumina. So those particular rocks of which they make up the continents are mainly composed of silica and alumina, therefore it is referred to as Sial. Sima, again, Si for silica, Ma for magnesia, and here we are looking at the heavier rocks, of which the sialic rocks actually lie on top of. So the Sial actually lies on top of the Sima. Sima is a more denser or heavier rock compared to the Sial. And again, the words are the first letters of the two main minerals which are found within that particular rock. Lithosphere, already we found out that it is to do with the crustal component of the earth. And we said from our definition that lithosphere is generally the zone of rocks. It includes the crust of the earth and also the uppermost mantle. And the uppermost mantle was the Asthenosphere that we were referring to when we were looking at plate movements. So when we put plate tectonics together, then it tells us that it is a scientific concept which was actually developed in the 1960s to explain the pattern of the Earth's structural components and the mechanism by which they were formed. And we know that this particular theory or idea is actually aided by the process of convection currents within the mantle. It is the process of convection currents within the mantle that aid in the movement of plates. Asthenosphere, this particular layer, very important. It's a geological term for the zone of the Earth's mantle, which lies immediately below the lithosphere, or in other words, the uppermost mantle is referred to as the asthenosphere. And we note from what we have studied already that the asthenosphere is supposed to be a molten layer. And because it is molten, it can be moved, or it is mobile. So this is those are some of the terms that we have already looked at. And today what I'd like us to move on to now is we're still dealing with plate tectonics. And with the work that we've done on plate tectonics now, we need to look at the movement of plate tectonics and the features that are created as a result of those movements. Over to the monitor, if you look at the information that's presented there, it tells us that the Sial, which is the continents, and the Sima, mainly the ocean floor, that make up the lithosphere are made mainly of igneous rock. The lithosphere is divided into a number of plates, of which those plates actually float under the mantle. We've already found out that convection currents within the mantle, they cause these plates to actually move. The movement of plates then will see us look at when plates are actually drawn apart. And when plates are drawn apart, the term that we use to describing that movement is divergence. Or when plates actually move towards each other, and the term we use to describing that movement is convergence. Where plates actually meet when they are moving either away from each other or towards each other, or when they are actually sliding past each other, where plates meet, the Earth's crust is unstable, and that's important. So if we had to look at plate tectonics and the boundaries for each of the plates that we have made a list of yesterday, the boundaries of the plates are usually unstable areas of the Earth's crust. These are areas whereby earthquakes, volcanism, and crustal deformation, that is folding and faulting, occur. And most of those occur along what we call plate boundaries. We'll move on with the information now on the chart, of which the information from the chart here will give you a simple illustration of plate movements and the features that are formed as a result of those plate movements. There are three plate movements that we must actually know about, and the movements are: one, movements where plates are actually moving towards each other, and the arrow there simply indicates that movement. The term we use to describing that movement is convergence. Some people might say plates collide, and when they talk about collision or colliding of plates, it is still referring to when the plates are moving towards each other or being pushed together. That's a simple illustration to show the first movement of convergence. The second movement is that of when plates actually move away from each other. And the term we use to describing that is divergence. Divergence of plates are simply when plates move away from each other. The third movement that plates also do is that of when plates are sliding past each other. And this particular movement, you can see one plate actually moving past the other plate. For the first movement, plates pushing towards each other. That's convergence. The second movement, plates moving away from each other. And the third movement is that of plates sliding past each other. So those are the three movements that plates would usually do. So we go back to our work on plate boundaries, and if you look at the map containing the major plate boundaries and the many other plates, you would have seen that the arrows at one stage where the plates are moving, they would meet together with another plate, or they would move away from another plate, or they might be sliding past each other. And the arrows on that particular map or on the maps of tectonic plates should be able to help you see that or see those three movements. We're going to do an activity, and that activity later on is going to see whether we can identify the major plates or the main plates, whether they're moving towards each other, moving away from each other, or are sliding past each other. Are we now familiar with those three movements? Okay, we'll move on. Beside knowing about plates moving towards each other, away from each other, or sliding past each other, those movements are very important because these movements then would contribute now to the many features that we see on the surface. So we'll start off with the first one here of plates converging or moving towards each other. Note, plates can be continental plates of which the continents actually sit on, or they can be oceanic plate of which the oceans actually sit on. If we have a continental plate meeting another continental plate, like in the example of the Indo-Australian Plate of which the country India actually sits on, meeting up with the Euro-Asian Plate, then what is actually created along the middle or the boundary then is the uplifting or the buckling of the Earth's crust. And when that happens, fold mountains are formed. And this, we can look at an example of the formation of the Himalayas. So if you look at the Himalayas, you can make reference to your maps. You look at the Indo-Australian Plate, the Euro-Asian Plate, where they are meeting, continental plate meeting another continental plate, fold mountain is formed along where the boundary of those two plates meet. An example then, the Himalayas fold mountains. We're still looking at plate convergence or plates colliding. When one plate is of oceanic and the other plate is of continental, we check. When they meet or when they move towards each other, then note, the oceanic plate being the lighter plate will subduct or will be forced under the continental plate, which is more denser or heavier. I'll repeat again. When an oceanic plate meets up with a continental plate in this particular process here of convergence, then what will happen is that the lighter plate will actually be forced to go under the heavier plate. This is the heavier plate because it contains the continent. This is the lighter plate because we found out already from our characteristics of the crust that it is thinner under the oceans and it is thicker under the continents. So the heavier continental plate with the oceanic plate, when they meet, the oceanic plate being the lighter plate is forced under, resulting in the process of subduction. When this happens, a feature which is actually created would be usually where the oceanic plate is meeting up with the continental plate, formation of what we call trenches. A trench is actually formed when plates converge, usually oceanic plate meeting a continental plate or an oceanic plate meeting an oceanic plate. When an oceanic plate meets another oceanic plate, the lighter of the two will subduct, resulting in the formation of a trench. Other features which are created as well, beside the trench being formed here, is usually on where the continental plate is. If a continental plate meets an oceanic plate, the buckling of the Earth's crust, not in the center here where they meet, but usually on the continental plate, the buckling then resulting in formation of fold mountains. So we can now look at an example. And here, if you can refer to the Nazca or the Pacific plate. If you look at your maps, the Nazca or the Pacific plate is an oceanic plate. The South American plate carries the South American continent. So if we look at the Pacific plate, or let's make this the Nazca plate. The Nazca plate is meeting with the South American plate. Is that true? That process then is convergence. Therefore, where they meet, an ocean trench is actually formed. Meanwhile, on the continental plate, there is the range of mountains which are referred to as the Andes. You see the Andes is the fold mountains. That's how they were actually formed, from the convergence of the oceanic plate meeting a continental plate. Other features which are also formed as a result of this movement too is that wherever there are continental plates meeting another continental plate or oceanic plate meeting another oceanic plate, there will always be volcanoes. Volcanoes are formed because here we are looking at the movement of magma up onto the surface, and where there are mountains or peaks, those magma can come out through them, forming volcanoes. Okay, so volcanoes are also a common feature which is formed as a result of plates converging. Beside volcanoes, fold mountains is another feature. Beside fold mountains, especially where the oceanic plate meets a continental plate, a trench is formed. And all of these areas also, because of plate movement, what do you think would be also felt because of that plate movement? Earthquakes, yes. Earthquakes are common. So we've looked at 4 features now with this. The 4 features again are: 1, when plates converge, fold mountains are formed. 2, when plates converge, trenches are formed. 3, when plates converge, you can expect to find volcanoes. And 4, where plates are moving or where there are tectonic plate movements, earthquakes are felt. Those are some of the features which are commonly associated with convergence of plates. Any questions? No? Okay, let's move on to the second or the next movement, and that's the movement of divergence. When plates move away from each other or they diverge, the main feature that is actually created as a result of this movement then would be the creation of what we call ridges. Mid-oceanic ridges, because most of those ridges are found in the oceans. A lot of people think that when plates are moving away, there's going to be a very big gap here, so a trench should be formed there. No, that is wrong. When plates diverge or when they move away, what comes up onto the surface is that magma. It comes out and it solidifies, and when it solidifies, it usually forms the ridges. So the common feature which is created as a result of divergence is that of a ridge. Remember that. Also, I mentioned earlier on that wherever there are plate boundaries, you can also expect to find volcanoes, and earthquakes are also commonly felt. So beside the ridge here, we can also put in volcanoes, and earthquakes are felt wherever there are plate boundaries. Okay, note an example, if you can make reference to the North American plate. If you can look at your maps, you look at North American plate and you look at the Euro-Asian plate. Can you see the arrow? They're going away from each other, they're diverging. So along that area where the plate boundary is, there are a lot of mid-oceanic ridges that are formed there. So a ridge is a common feature of divergence. Finally, the last or the third movement is that of when plates are sliding past each other. And when plates slide past each other, the main feature that is created is that of what we call a transform fault. Very good example of this will be that of the St. Andreas Fault in Los Angeles. It's a transform fault. And that is formed as a result of one plate, the Pacific plate moving towards the north along that area, the American plate moving down towards the south perhaps, and then where they are sliding past each other, this feature is actually formed. Again, don't forget, where there are plate boundaries, volcanoes are common and also earthquakes are common. Let's look at the information presented on the monitor, and then I'll give you time then to do some activities. The first diagram here on our monitor, it actually shows us information about plates moving away from each other. So here we are looking at an example of divergence. Moving away, features that are formed. The common feature I'd like you to make note of is that of the Oceanic Ridge. Again, I'll emphasize the point. A lot of people think that when plates move away, a trench is formed. That's not true. When plates diverge or they move away, oceanic ridges or ridges are formed. Remember that for plate movement of divergence. Second example here, showing us where plates are moving towards each other. As explained, if one plate or if at least one of the plates is of oceanic lithosphere and one plate will be subducted into the mantle and a trench would be formed, as well as that another of those important features, especially for a plate which is of oceanic lithosphere. Beside a trench to be formed here, there is also volcanic arc which will be formed. And volcanic arcs are simply a line of volcanic islands that can be created as a result of that movement. So here we are looking at a volcanic arc out there at the ocean, a trench which is also formed along here. And then on the continents itself, the continental plate where they are meeting, we are looking at the formation of the fold mountains, which are, example, the Andes. So here, the South American plate meeting together with the Pacific or the Nazca plate. If we look at the volcanic or oceanic crust under the ocean, or let's say the oceanic crust that is, and we're looking at the volcanic islands or arcs which are developed. These are examples of the volcanic islands or arcs that are developed, and these have been formed as a result of one plate, oceanic plate, meeting with another oceanic plate. Where they meet, a trench is actually formed, this area here, and at the same time, you can have volcanic islands or arcs being formed. And here we are looking at an oceanic plate meeting with another oceanic plate. Again, the movement is still that of convergence, moving together. Where we have an oceanic plate meeting a continental plate, we've already done this, but let's look at the diagram again. Oceanic plate subducts, moves under. On the continental plate, you have features like a mountain belt or fold mountain being created. And those fold mountains are as a result of the movement of plates which are of that of converging. But on the continental plate, you have the range of mountains here being created as a result of that movement. So if we look at a cross-sectional view of the crust and the upper mantle and those features that we've just basically looked at, you have the divergence here, ridge being formed. You have the convergence on this side here, trench being actually formed along here, and at the same time, fold mountains being created mainly where the continental crust is. On the oceanic crust, you also have volcanic arcs or volcanic islands being created, and areas along where the plate boundaries are, you can expect to find volcanoes being formed or created. Okay, and I think with the explanation that we're going to look at on the monitor, that's basically what I've already explained on what happens when a continental crust meets another continental crust or plate, and what happens when a oceanic plate meets up with a continental plate. And that information we have already looked at with what is here on the chart. One of the things that we can actually identify easily to tell us that we are looking at the edge of a plate, or what we call plate boundary, is looking at what we call a line of volcanoes. The Pacific plate, it is easy for us to identify the Pacific plate because we can simply look at the volcanoes which form what we call the ring of fire. And that ring of fire is a group of volcanoes or a line of volcanoes that actually marks the edge of the Pacific plate. So we can say that volcanoes are common features that can also tell us that we are looking at boundaries or edges of tectonic plates. Using the plate tectonic maps that you have been issued with, what I would like you to do now is I would like you to do the following activities. I'd like you to name at least a couple of plates that appear to be colliding or to be moving towards each other. B, I'd like you to list or name at least a couple of plates, tectonic plates that are moving away from each other or diverging. And the third activity I'd like you to do, referring to your maps of the tectonic plates, identify which two plates collided to form the Himalayas. Okay, so make a list now of all those plates that are converging. Make a list of all those plates that are diverging. But you cannot just make a list by saying Euro-Asian plate is converging. No, you have to say Euro-Asia plate with which plate. So there must be two plates to identify whether they are converging or whether they are diverging. And you are only doing for the first two movements, converge and diverge. You can discuss with the person sitting next to you so that you can come up with your list quickly. Okay, have you made note of those questions? Simply make a list of the plates that appear to be colliding or converging, and then make a list of plates that are moving away from each other or diverging, and then also identify which two plates collided to form the Himalayas. Okay? Those two questions you're doing now. So what do you mean African plate only? African plate and what plate? It has to be two plates because then you would see the movement. If you just say African plate, what? African plate, what is it doing? Is it diverging with another plate or is it converging with another plate? So it must be two plates. Exactly. That's how you're supposed to write it down. Okay. Any others that you can actually think of beside those two? Double check. Okay, we'll check on the maybe answers to those information. They're simple and straightforward.
Like this way, or Untitled Plate with the African plate?
You have the African plate.
African plate here.
It's moving there. Antarctic is a divergence? Yes, definitely. Definitely. That's what you're supposed to look at. It. Okay, perhaps if you did not have all of those different examples, the other students might have them, and then you can add to your list. Okay, let's look at the first one where plates appear to be colliding. Don't forget, you're supposed to look at the arrows from one plate boundary or tectonic plate meeting with the arrow from another tectonic plate to say that the plates are colliding. Moses, can you give me an example of two plates that appear to be colliding? And the rest of us will check and make corrections.
Nazca and South America plate.
Okay, everyone check the Nazca plate and the South American plate. Arrows pointing towards each other? Yes, definitely. And we're happy with that as the first example given. Good. Okay, let's move on. The second one, Frank. Give us another example of two plates that appear to be colliding.
The Pacific Plate and Euro-Asian Plate.
Okay, everyone check the Pacific Plate, the Euro-Asian Plate. Pacific Plate, Euro-Asian Plate, yes? Okay, good. If you have that, that is also correct. They appear to be colliding. That means you find them moving towards each other. So we had the first one, Nazca Plate with the South American Plate, yes? They're colliding, converging. Euro-Asian Plate with the Pacific Plate, definitely see the movement. Colliding, correct. That's the second example. Any other examples of two plates appearing to be colliding? Any other examples? Ovio, next to you.
The Euro-Asian plate and the Australian plate.
Euro-Asian Plate and the Australian Plate, all check, yes, definitely. If you're looking at the Australian Plate here, Euro-Asian Plate, we've already said that the formation of the Himalayas was as a result of that, so therefore we'll accept that, definitely. That's the third example. Any other plates appear to be colliding? Mason? No? Val? Kathy? Do we all have only those three answers that were given? Or anyone with any other example that you can see? Okay, we move on. Let's look at divergence this time. Kathy, and we'll go across that way. Give me an example of two plates that appear to be diverging or moving away from each other.
The South American Plate and the African Plate.
South American Plate and the African Plate, all check. We happy with that? Okay, definitely. If you look here, South American Plate going that way, African Plate that way, diverging. Okay, that's the first example. Other plates appear to be diverging.
The African Plate and Antarctic Plate.
Okay, good. The African Plate and the Antarctic Plate, they're diverging. Good. That's the second example. The third example.
The Antarctic Plate and the Australian India Plate.
Okay, the Antarctic Plate, the Australian Plate, or the Indo-Australian Plate, correct? That's the third, is it third or fourth example? The third example, okay. Next one, any other examples of plates diverging?
The Euro-Asian Plate and the North American Plate.
Okay, very good. We have the Euro-Asian Plate and the North American Plate. Okay, they are diverging. Dorothy, any other examples?
Pacific Plate and the Nazca Plate.
Okay, we all check Pacific Plate and the Nazca Plate. Yes, definitely Nazca, Pacific, correct. Any more examples? Gideon at the back? Or Catherine, do you have an example first? Any other examples to be included? Okay, Catherine will give us another example before we get the mic down to Gideon.
The North American Plate and the African Plate.
Okay, North American Plate, all check. North American Plate, African Plate. Yes. That's correct, North American and African, South American and African. Any other examples, Gideon?
The Antarctic Plate and the Pacific Plate.
The Antarctic Plate and the Pacific Plate, all checked? The Antarctic Plate and the Pacific Plate. Check from that monitor and also check from the other sources that you have. Antarctic Plate and the Pacific Plate. To which direction is the Pacific Plate moving? Towards the east. The Antarctic Plate towards the south. No? Okay, we will not accept that. So that answer not accepted. Yes, Gibest?
The Antarctic and the Australian Plate.
The Antarctic and the Australian Plate already given. Okay, thank you, Gibest. Okay, so we'll move on then to the last question. And the last question is to look at which two plates collided to form the Himalayas. And I think that is straightforward from what I have already explained here. It is the Euro-Asian Plate together with the Indo-Australian Plate. Okay, let me give you your homework. And the homework that I'd like you to actually do is, we did examples of listing the plates that converged and the plates that diverged. So for your homework, what I'd like you to do is, I'd like you to list examples of plates that are sliding past each other. So examples of plates sliding past each other, that's the third movement that will be done for your homework. Okay, that also brings us to the end of our lesson. Class, if you can now stand up. To the pilot teachers, our keyword for lesson 23 is Australian Plate. Good afternoon and thank you, students.